So let me pull up MATLAB. Come on, MATLAB. Not today, MATLAB. Oh. These are bad. Really? Alright. Windows Explorer crashed, so that's not good for me. Windows Explorer. Okay. My computer realizes it's Friday. All right. So you see my MATLAB screen here, and then let's see, you can follow along from the class drive about what the particular problems are, but we're going to do problem 12 from the review first. So write a loop that will run forever, printing hello to the screen over and over and over. Okay, fair enough. So if we want to do something for an undetermined amount of time, we'll use a while. This one we want to do something forever, so we can say while 1, that's a true value, and it will never be false, it will be here forever. And then we can just say disp hello, like that. And so if I run this, I will get a lot of hellos. Yeah, right? Get out of here, just Control C, and then we'll be done with that. All right, number 14, a while loop that will generate and print 2 random integers between 3 and 10. Continue doing so until, all right, so this one has a bit more going on. So again, we don't know how long this is going to take, so I'll just say while 1 here, and now I want a random integer between 3 and 10. So you can use the help tools to figure out the parameters to call randi with here.
Sir, I think you mean Randy.
I mean Randy. That's what I mean. Right? Remember to put the brackets around here. You could also do rand, my favorite, times 7 here, and that'll give you a value between 0 and 7. And then you would say plus 3, right? And then we would say round that thing out. So if you don't want to worry about how to use Randy, you can use rand. You can always use rand. Rand's the most general purpose random variable generator. But I think for this question, Randy sounds good. Goodness. And so it's going to get two of these, so x and y. And then it's going to print them out, fprintf. And then let's see, until the numbers are both even, at which point it will terminate. So if mod x comma 2 equals 0 and mod y comma 2 is 0, then break. And we'll put semicolons here. All right. And so you see it goes and prints numbers until it gets 2 even numbers. So this is looking at your ability to do comparisons with the double equal sign, and then combine multiple comparisons with these Boolean operators. So I guess a lot of the stuff was from the MATLAB on-ramp. We didn't cover it directly in class. But do you recognize these double and signs and the... Yeah, okay. And what if I wanted to run it until one or the other was even? Rather than requiring both to be even, what would I replace the double ampersands with?
To get in where you do the double vertical lines.
Yeah, double pipes. So that would be
What
or.
What are they called?
Pipes. Well, I should say it depends on where you're coming from. In Linux, they're used to pipe outputs to different places, so we call them pipes. But, yeah. Okay, so this would be or. We have or and are ways to put together these called Boolean expressions to create something that's, testable in an if statement. All right, that's number 14. Number 6.
Professor, can you please explain again what the mod function does?
Yeah, the mod is the remainder. So divide x by 2, and if there's no remainder, then it's even.
Okay, thank you.
Yep. So what's next? We've got number 6. Print x and y are close when x minus y is between -2 and 2. That's good. Okay. So here maybe we'll just practice getting information from the user. We'll say x equals input. Give me an x. Y equals input. Give me a y. Right? So now we have x and y. And, okay, diff is equal to x minus y, sure. And my question is if the absolute value of that difference is less than or equal to 2, then this x and y are close. So let's give that a shot. Give me an x, 3. Give me a y, 100. Nothing. Give me an x, 3. Give me a y, 1. No, wait, 1.2, 3, whatever. X and y are close, right? And we can try the other way around. 1.3 and 3 should still be close. Yes, they are. Okay, so here we're using a built-in function, absolute value, to test both sides. You could do 2 different if statements here. That'd be fine. But I think an absolute value is a bit cleaner. Let's see, number 16. Number 6, 10, 11. Okay. Yeah, all of them. Yeah, okay, great. Okay, so let's see. Number 6 we just did. Number 10, write a for loop that makes an array of 1,000 values that's small to 120. So we can do that. So for I equals 1 to 1,000, my array I equals 120. And when I run this, we can see that my array is a lot of 120s, all the way out to whatever, thousands, right? So there we go. 11. Read 300 from the keyboard to A, B, and C. If C is larger than A, write a loop that counts from A to C in steps of B. Blah. What a mess. Otherwise, write a loop that counts from C to A. Whoever wrote that had a masochist. All right, so 300 in the keyboard. A equals input A. B equals input B. C equals input C. Right? Okay, so if C is greater than A, then we're going to have a loop that counts from A to C for I equals A like this. So we're going from A to C in steps of B. And then we can just say I Otherwise, write a loop that counts from C to A in steps of B. So else for I equals C like this, I end. I guess that's interesting. Let's try to run it. So let's make A small like 1. Let's make B 2 and make C 10. Then we count all the way up by 2s, so 1, 3, 5, 7, and 9. We can't hit 10 exactly, so we'll end at 9. The other way around will be 10, -1, 1, and then what do we have? 10, and then so if C is greater than A, and now A is going to be greater than C, all right, so we want C to be larger. A is going to be 10, B is -1, and C is 1. All right. Sorry here. C to B to A. Oh, right. We're always going up here. Sorry, confusing myself. I write the right answer and then I do the wrong inputs for it. Right. So now it's going up, starting from 1, going all the way up by 1s to 10. Sorry for the stumble there. I think that is a manic question. I don't expect you to see something quite like that. Yeah.
Would you need to make B like, or would you need to take the absolute value of B there so you wouldn't run into?
Yeah. Right. Yeah, you could say, I'm going to make sure that B is a positive number. Yeah. That way you won't get in trouble. 13, what do we have here? Write a loop that revalidates the keyboard, printing out the square root of the number until it receives a negative value, and then it panics, right? So anytime we don't know how long we're going to do something for, we'll use a while loop. X equals input X. And then we'll want to calculate the square root only if it's a positive value. So if X is less than 0, break. Else square root of X without semicolon, we'll print that out. And so then we can say X is 9, we get 3, but if it's -1, then it breaks, right? 14, write a loop that'll generate, we did that already. And 15, show how to use code to determine the size of each variable. Okay, so let's go ahead and give ourselves these variables. I'll just do this in the command window here. So A is a scalar, that's just a flat number here. V is an array. And M is a matrix. All right, so those are the 3 different types of things here. Size M gives you 3 by 3. Size V is 1 by 4. And size A is it okay? Yeah, A is a 1 by 1. So really everything in MATLAB is a matrix. And a scalar is just a 1 row by 1 element. Or sorry, 1 row by 1 column. And did I get them all? Yes, I did. All right. I'm surprised nobody asked about the functions. I didn't have a chance, of course, to go through your quizzes in detail to see if you all figured that out, but the function syntax is kind of complicated. So make sure you are familiar with that. How to take in one or more inputs, how to produce one or more outputs, how to call a function, the restriction that the file name has to match the function name. All right, and 16 III, what is that? Oh, the 33rd column. No, wait, 16 triple I. Every third entry starting at 1. Okay, so let's give ourselves a V by 100 equals 1s, 100. So there we go. It's a super long set of 1s. And we want every third entry starting at 1. So we know that the so V looks like that. Length of V is 100. So if you didn't, I mean, you could hard code that, but we don't need to. We can say V, and we can get starting at 1, counting up by 3, all the way to the length of V. Right? And that'll give me just the third entries, or multiples of 3, I guess. Sound good? Okay. All right, so not on this practice problem sheet, but very important for the exam is your ability to read and write pseudocode. So you should be able to read an algorithm like the homeworks or the in-class exercise you've done on like sorting or finding palindromes. Right? I don't expect you to be able to write the code to sort a list, but you should be able to read code and sort of figure out what's happening. You should be able to express an algorithm to solve a task given a set of library functions. And then if, while, and for structures to put together those library functions to solve a problem. Okay? And I think that is about it. Again, there won't be anything specific to graphics, but all of the tools we've used to build that game are testable. Right? The ability to write a function, call a function, slice up arrays, for loops, all that stuff. The labs, again, you should be able to do the labs, but we're not going to test it with GPS, format strings or something like that. All right. I wanted to go through this on Friday rather than on Monday in order to give you time or some resources over the weekend if you were stuck on one of these practice problems and just couldn't figure it out. There's no reason for you to be frustrated over the weekend. But I will give you an opportunity on Monday to ask questions. So if over the course of the weekend you've studied and realized, hey, I thought I knew functions, but I don't, I'll reserve the last 20 minutes of class on Monday for exam review as well. Anything else? Any other numbers that I haven't gone over that you think would be useful to see? Let's see, 21 we have. Okay, write a function will take two arguments, return their sum, difference, and product, include the complete file and file. Yeah, good. So, thank you, Megan. I was hoping somebody would ask me to write a function. I've just been wanting to write a function, right? So, we've been using the shortcut to right-click in the current folder to say create a function, and when you do that, it puts together a template for you to edit, but you don't have to do that. You can just simply create a function yourself by writing the right words. We can say function, right? And then we'll put the return values here. So we want to return the sum, difference, and product. I could call these X, Y, and Z, but I might as well give them meaningful names. And then equals exam question 21. And then I expected to get two values, X and Y. You're totally at liberty to name X and Y, some difference in product, whatever you want. It doesn't matter. So then sum is simply equal to X plus Y. Difference is X minus Y. And product is X times Y. Right? And if you do that, your code should go green. No warnings found. Good. The other thing to make sure you understand is that the name of the file, here it's untitled 2, that won't work. We need to call it exam Q21. So if I say Control S here, and I save it as exam Q21, then I can call my function by saying exam Q21, 10, 5, 4, whatever. If I call it like that without explicitly catching all the values coming back, I'll only catch the first one into ants, right? MATLAB will automatically create this variable ants, kind of like answer, and catch the first return value. If there's more than one return value, I have to do it explicitly. I have to say SDP equals exam Q21, 10, 4, and then you see the sum, the difference, and the product come out. Okay? So the reason MATLAB has you declare a function using this funny notation is because that directly reflects how you use the function. But it's important for you to understand that the names that you give to the values here inside your function are totally independent of the things that you end up calling it with. Right? This is kind of like the instructions. Okay? And I can use the instructions to actually execute on a particular set of values here. Sometimes I see you guys like smile, like you really like this, but then I realize you're probably chatting with somebody, and then, but maybe you really like my sum difference product function. A real grin comes across your face. All right, does that answer your question? Oh, and then when you submit these, again, we'll use this Google Forms thing. So rather that you won't be able to write a file and upload it as .m, I would ask you to then after you write this function, and if it asks you other pieces of information, like for example in 21, include the complete file and the file name. You know, in that quiz, I asked you what's the file name here. Just use a % sign to indicate that you know it's going to be a comment, and say the file name must be exam Q21.m. And so then you could just Control C, Control V this into the Google form, and that would be good. If it asks you other stuff like call it using these parameters, how would you call the function? Then just do it down here, you know. And then you can just you know, put in this bit of information. Okay, so that's how I would like you to answer questions that ask you to do more than one thing. You know, as far as a MATLAB function.
And so we're allowed to use MATLAB
Oh yeah.
to test the functions and then submit them, right?
I would encourage you to do that. Yeah. You know, manage your time. I think if you decide like, wow, it's all open resources, I won't study a wink. I'm sure you'll be able to do fine on the exam, but you'd probably have to take a few hours to do it. So you'll only have the 15 minutes during the class period, and so use your time wisely. But if you'd like to run all the code in MATLAB and verify it and check it, that's good. That's great.
Are we allowed to do that for the quizzes as well?
Oh yeah, everything in this class is open resources.
Oh.
Game changer. Yeah. You know, I think if we were in person, it would make sense to restrict access to resources. But, you know, I would like to say is train as you fight. Go ahead and use the resources out there. This class, we do typically restrict the resources when you're in person. But when I teach the senior electives, I always give them full access to everything, even during the final exam. Because I remember as a student being very frustrated as like, well, why would I memorize this if I can just Google it later on? And so I would say, great, use Google. Use all the resources you can. There's still hard problems out there in the world. And yeah, so long answer to your short question, but you're welcome to use any resource. You may not post questions to a forum or call up Andrew, you know, no Minecraft chats, Hannah. Connor from space. All right. Nothing else. Everyone's pretty confident or pretty ready to be done. Okay. Both. Good. All right, then I'll let you go 2 minutes early here. I'll have to decide whether to do numbering systems or tweak the video game, but we'll probably do numbering systems on Monday. And then Friday, I'll start you off on the game project, and you can start building your own video games. So that'd be cool. Okay. Have a great day. Have a great weekend. Stay safe out there. I'll see you on Monday. Make sure you're working on that lab.
Thank you, sir. Have a good one.
All right, you too.
Professor.
Have a great weekend.
Thank you, sir.
Bye.